Okay, guys, so we are going to talk about today about the area of trapezoids, rhombuses, and kites. So let me remind you a couple things before we get too far, that the sides of the trapezoid are called its legs on the top and bottom, or more specifically, the parallel sides. They don't have to be the top and bottom, but the parallel sides are called its bases. So this is the sides that are the bases, and this is a leg, and this is a leg. Okay, and the height of the trapezoid is the length of an altitude, just like it was for the triangle, just like it was for the parallelogram. It's that segment that goes from a vertex, from a corner, and is perpendicular to one of those bases. That's going to be your height, is the length of that red segment, that altitude there. So the area formula for a trapezoid is going to be height. And just like all the other formulas we looked at, they were all base times height, right? This is still height times base times height, same thing, except for we have two different bases, two different lengths. So how do you know which base to use? Well, what we're going to do is we're going to take the average of the bases. Take B1 plus B2, divide it by 2, and that average length of the two bases is what we'll multiply times the height. So we can think of the formula as the height multiplied times the average of the bases. Okay, so I'm going to let you, well, here, we'll walk through the first one together, right? So the formula is height times B1, B sub 1 plus B sub 2 all over 2. And you'll see that written different ways. Sometimes people will write that as 1/2 height times B1 plus B2. That's the same formula, just written a little different. Okay, in this case, my height, the length of that altitude connecting a vertex perpendicular to a base, is the 6. B1 is 6 and B2 is 10. So that would look like 6 times 6 plus 10 all over 2. So I know order of operations, I do it's in parentheses first. 6 plus 10 is 16, divided by 2 is 8. So that's 6 times 8, or 48 centimeters squared. Okay, I'm going to let you in your groups work through the rest of these examples and check your answers with the key. If you want to pause, well, we'll go ahead. I'll tell you what, we'll just go on over here. So the area for a rhombus or kite is a different formula. It's the diagonals. So here's one diagonal, here's another diagonal. It's those two diagonals multiplied times each other divided by 2. So 1/2 diagonal 1 times diagonal 2, or D1 times D2 all over 2. However you want to think of that. Okay, it doesn't matter if it's a kite or a rhombus. So for example 2 here, we have the area would be this entire diagonal is 16. This entire diagonal, 11 plus 9 is 20 all over 2. So 16 times 20 is 320, and 320 divided by 2 is going to give us 160 centimeters squared. Don't forget that the area is always units squared. So your homework, let's look at example 4 real quick to make sure we're good on that. So in example 4, you're doing the same thing. This is still a kite, and to find the area of it, we're going to do 1/2 diagonal 1 times diagonal 2. The only thing that's going to be different here is you have to draw your own diagonals in. You have to find the length of them and then multiply them together in the formula, right? So we know that to find the length of that diagonal, the fastest way is to make a triangle here and do the Pythagorean theorem. So in this blue triangle here, my sides are 1, 2, 3, 1, 2, 3. So my first diagonal, if I go to my side work over here, 3 squared plus 3 squared equals c squared. So that's 9 plus 9. So that's square root 18. So my first diagonal is going to be square root 18. And then if I go to my other diagonal, let's look over here. from here to here. See, and I'm going to draw in the rest of that right triangle for the Pythagorean theorem. This one also has a rise and run of 3. So it's going to also be times square root 18. And then, guys, square root 18 times square root 18, isn't that square root 18 squared? So really this square and the square root would cancel, so that's 1/2 of a plain old 18. So it's 9 units squared would be the area of this kite. Okay, so now fast forward, your homework is going to be, you have 3 of these grid problems at the end of your packet, and then you also have Math Excel, okay, over area of trapezoids, rhombuses, and kites. So I want you to, with your groups today in class, work through these examples in the note packet, and then if you finish early, you can start on the homework. Okay, I hope to be back Monday, and I'll see you then.